Alright, this is Module 21, Prove Triangles Congruent by SSS, which stands for side, side, side. The theorem that you have to know is the side, side, side congruence postulate. It states that if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are going to be congruent. So in a picture, if we show, for example, remember the double dash marks, the single dash marks, the triple dash marks, those indicate what sides are going to be congruent. If we show in a proof or in an example, a numerical example, if we show that all three sides of one triangle are going to be congruent to the corresponding three sides of another triangle, we can state that the two triangles are going to be congruent by the side, side, side. Again, you have to be sure that you go in the order, like we went ABC, because ABC goes along the one dash mark and then along the two dash marks. That means you have to do the exact same thing for FEG. So FEG is one dash mark, then two dash marks. So be careful of your name, which is the ABC's triangle congruent to FEG's triangle. Okay, so it says decide whether the congruent statement is true and explain your reasoning. So the first thing you have to look for, always, is you have to look for reflexive property. Because I have two triangles here. I have one triangle and I have two triangles. These two triangles actually have a side in common, which is HJ or JH. I can immediately label those as congruent because they belong to the two triangles belong to the same side. Now the statement that's being said is we have IJH or IHJ. IHJ goes from the two dash marks to the three dash marks. Does JHK do the exact same thing, exact same orientation? J goes along the three dash marks, then along the two dash marks. So the orientation is not the same, so this is no. Orientation not the same. Okay, so let's go with number two. Again, look for the side that they have in common. In some cases they have it, some cases they don't. So I see that they have LP in common, so I'm going to label it. And it has to be a different label than the other two labels, or the ones that are already labeled. So we have LPS. So LPS, you go along the three dash mark, then along the one dash mark. PLN, we have along the three dash mark, then along the one dash mark. The orientation is the same, so yes, because same orientation. Okay, what about three? Three is one where they don't have a side in common, but everything is labeled for you. So we can say ACE and see if they go along the same orientation as BDF. So ACE, we go along the one dash mark, then along the three. BDF goes along the two dash mark, then along the three. So these would be no because of not the same orientation. What about number four? Number four, they have a side in common, so I immediately label it. And now I see if the orientation is accurate. So STV, S is along the one dash mark, then along the three. UTV, we have U, one dash mark, then along the three. So these would be congruent, yes, because of the same orientation. So, okay, so now we have a proof, and I have again, I want to emphasize label as you go along in the proof. We have two triangles that we're trying to prove congruent, which would be triangle ABC and triangle CDA, which is this guy and this guy. So, what am I always starting off with? You always start off with the given. AB is congruent to CD, BC is congruent to DA. So we label those, and remember to label those with different dash marks. I have AB and CD as one dash mark, BC and AD or DA as two dash marks. the next thing that I see is that these two triangles have a side in common. So I immediately can say that AC is congruent to itself because of the reflexive property of congruence. And I label them with 3 dash marks because, again, those sides have to be labeled congruent. Now here's the thing. This is a 3-step proof, and we're actually done with the next step. I can prove that triangle ABC is congruent to CDA's triangle because I have 1 dash mark, 1 dash mark, 2 dash mark, 2 dash mark, and 3 dash marks for the third side. 3 sides of this triangle are going to be congruent. So that means triangle ABC is congruent to triangle CDA by the side-side-side congruence theorem. Now with side-side-side congruence theorem, you do not have to put side-side-side congruence theorem. You could just put SSS, and I will know what you mean. Alright, so here we have another proof. This one's slightly more difficult, but again, we have 2 givens in the first step. So start off with a given. Wx is congruent to Yx. That's given, and I label it in the actual figure. The next thing that's given is z is the midpoint of wy. Well, if we know that z is the midpoint of wy, we can actually conclude something from that. What is the definition of midpoint state? Well, if we know that z is the midpoint sounds like middle. This is from a previous module. That means I can state that wz is going to be congruent to yz's segment. Wz is congruent to yz's segment. That's because of the definition of midpoint. Now, number 4, you've seen this about 5 or 6 times throughout this module. Reflexive property of congruence. What is the side that they have in common? Always look for that. So the side that I see that they have in common is going to be xz. So I can say that xz is congruent to xz because it belongs to this triangle and this triangle. And the 5th step, always, always, always you end with what you're trying to prove. And we have triangle WXZ is congruent to YXZ. And that's by side, side, side. Again, you can put congruence postulate or you can just put side, side, side. It doesn't matter. But the first 2 steps should be pretty straightforward. This step is from module, I think, 2 or 3. It is from one of the beginning modules. This step is from Unit 2, the reflexive property, and we used it quite a bit in Unit 2 and in parts in Unit 3 as well. So this is, again, the kind of caliber proof that you will be running into in this chapter or in this module.